Good morning. We continue the formulas for integer exponents. Yesterday, we covered the 5 of the 7 formulas. The 7 formulas behind me on the board. We did product rule, quotient rule, power of product, power of quotient. We have 2 more formulas left. We're gonna start from 7 and then we go to number 6. Formula number 7 on the board. It is x to the power of 0 is 1 for any given x non-zero. This actually is a definition. We can call this formula as a zero product formula. Sorry, zero exponent formula. Zero exponent. Let me repeat the content of this formula. For any given non-zero quantity. For any given non-zero quantity means as long as the base is non-zero. As long as the base is non-zero. If the exponent on the shoulder of the base is 0, then the power, the value of the exponentiation is 1. You can see that as a formula or is a definition actually. We define any non-zero quantity to the power of 0 equals 1. For example, let's look at number 1. What's the value of the expression? The expression obviously is a power. The base of the power inside the parentheses is a -½ The exponent of the power, which is the number on the shoulder of the base, is 0. Yeah, anyone can tell me the value of this expression by the definition right above it. The formula for zero exponent. The formula for zero exponent. We define any non-zero quantity to the power of 0 equals 1. So anyone have this value? No? Number 1. What is 0 power of -½ 0? No, it's not 0. The base is a -½ The exponent is 0. The formula tells us any non-zero quantity is raised to the power of 0 gives you what? 1. Yeah. Look at the number 1 again. What's the value of the power? Huh? Exponent is 0, right? Yeah, it's 1, of course. Do you see that? If the exponent is 0, the base, as long as the base is non-zero, then the power equals 1. Do you see that? Number 2. Let's see the value for -3 to the power of 0. -3 to the power of 0. I want to ask, how do you understand this negative sign here? Is the negative sign part of the base or not a part of the base? Huh? Is the negative sign here part of the base or not? -3 to the power of 0. Okay, see the difference between those two expressions. -3 to the power of 0 and -3 in a parentheses to the power of 0. Are they the same? They're obviously not the same, right? The one below, this one, the base of the power is -3 in a parentheses. The negative sign is part of the base. However, this one, the base is 3 the exponent is 0. The negative sign is not a part of the base. Do you see the difference? Okay, so for number 2, the negative sign here can be understood as opposite. That's the opposite of 3 to the power of 0. What's 3 to the power of 0? 3 to the power of 0 is a positive 1. The opposite of positive 1 is negative 1, right? Do you see that? Okay. I would ask you to work on number 3. Give you a little bit of time. What's the value of that expression? The expression is a negative 1/2 to the power of 0 minus negative 1/2 to the power of 0. What's the value of this expression? What's the value of the blue? What's the value of the green? Maybe we can figure out that. Lauren, what's the value of the blue? The blue, only the blue part. Yeah, exactly, very good. Look at the blue part. Base half is non-zero. Exponent is 0, so it's 1 by the definition, right? Yeah, please look at the green. Base is a negative half, right? Ian, what's the value for the green part? Exponent is 0. Base is a negative half, is not 0. Negative half is not 0. What's the value of it? Of the green? No, I mean this part. Only this part. Only this part I highlighted in green. It's 1 power, right? Exponent is 0. Base is a negative half. What's the value of it? Any non-zero quantity to the power of 0 is what? Yeah, it's 1. Okay? Yeah, the exponent is 0. Base is negative half. It doesn't matter. As long as the base is non-zero, that'll be okay. So the power is 1. So we have negative 1 minus 1. What's the value? Negative 1 minus 1. What's the value? Sorry, what's the negative 1 minus 1? The blue is a 1, the green is 1, right? So the expression is a negative blue minus green. What is the negative 1 minus 1? Negative 2. Exactly. Okay, you might wonder, what happened if the base of the power is 0 here? 0 to the power of 0 is undefined. Okay, 0 to the power of 0 is undefined. Yes?
So
why the green is a positive 1? That's a good question. Because the definition tells us if the exponent is 0, it doesn't matter what's the base. As long as the base is non-zero, the power equals 1. And let's look at the green. Exponent is 0, right? Base is negative half. Yeah, the base could be very complicated, but as long as the base is non-zero, the value of the power is 1, right? It's positive 1. Similar, it's same with here, right? Same with here. Blue part is 1 as well. Only look at the blue, that's 1. But then that is 1 power. Yeah. So the blue, that's 1. The green is 1. And with the negative sign in front of them, we have negative 2, right? Okay. Any question about this formula? It's number 7 on the board. Now let's go to number 6. That's the last formula we learned. The formula is called negative exponent. Negative exponent formula. The formula is x to the power of negative n equals 1 over x to the power of n. This formula is the negative exponent formula. It's number 6 formula on the board. Number 6 formula on the board. Okay, let's see. N here, by the way, is any integer, okay? N here is any integer. When do we apply this formula, and how do we apply this formula? We apply this formula to get rid of negative exponent. Yeah, let me repeat it. We use this formula to get rid of negative exponent. An expression is not simplified if the expression has negative exponent. Do you see what I'm talking about? Do you see what I'm talking about? An expression is not simplified if the expression has an exponent which is negative. So in order to simplify an expression, we need to get rid of negative exponent. Am I clear? Do you see what I'm talking about here? Yeah, so we use this formula to get rid of negative exponent. We use this formula to get rid of negative exponent. From this exponent, when the integer n is 1, we have another formula here. X to the power of negative 1 equals 1 over x. I'm going to prove this formula. Yeah, in the formula, if we let the integer n be 1, we have x to the power of negative 1 equals 1 over x, right? Yeah, I'm going to prove it. I'm going to take the product of x to the power of negative 1 and x. Yeah, anyone can tell me what's the product? If we multiply x to the power of negative 1 by x, yeah, I can give you a hint. X here actually have an exponent of positive 1, right? X is x to the power of positive 1. And what do you have? Look at the first formula on the board. Look at the first formula on the board. What's the name of the first formula we learned yesterday? Product rule. We use the product rule to multiply powers with the same base, right? Okay, are we multiplying two powers with same base? X to the power of negative 1 times x to the power of positive 1, right? Yes? I need your response because as I mentioned yesterday, we need to finish the whole chapter 4, whole chapter 5 this week. Yeah, we're gonna have a final next Tuesday in a week. And Monday is the test 4. So we really don't have too much time. I hope you focus and answer the question when I want to ask you. Yeah. 8 week. Yeah, this is 8-week class. Use the product rule to simplify this product. X to the power of negative 1 times x to the power of 1. Could we apply product rule? And how do we apply product rule? Yeah, if you were here, you should have the note. You keep the base and add up the exponents. Negative 1 plus 1, right? What's negative 1 plus 1? What is the yeah, okay, 0. X to the power of 0. What is x to the power of 0? Here, x is non-zero, by the way. X here is non-zero. And what is x to the power of 0? 1. Okay, very good. So we have x to the power of negative 1 times x equals 1. I'm going to divide both sides. This is an equation, right? Left-hand side equals right-hand side. I'm going to divide the left-hand side and the right-hand side by x. And they cancel, right? X over x cancel, right? So we have x to the power negative 1 on the left. On the right, we have 1 over x. That's the formula. x to the power of -1 equals 1 over x. How do you understand this formula? The -1 power equivalent to taking the reciprocal. Okay? If you apply -1 power on a quantity, it's equivalent to taking the reciprocal of the quantity. Do you see what I'm talking about? Reciprocal, we know what is the reciprocal, right? For example, reciprocal of 2 is 1 over 2. Reciprocal of 3 is 1 over 3. So you use 1 to over. Yeah. So the -1 power is equivalent to taking the reciprocal of the base. Yeah, you need to remember this formula. And we're going to use that formula to prove the formula, the negative exponent formula on the board. Let me show you how. So we are going to prove x to the power of -n equals 1 over x to the power of n. So we are going to prove this formula. Here, x is non-zero. We start from the left-hand side. Left-hand side is x to the power of -n. Could I write -n as -1 times n? Yeah? Okay. Could I write -1 times n as n times -1? Same thing, right? N is n times -1. So far, so good? Okay. And then I'm going to use the power rule we learned yesterday. We're going to use the power rule from the right to the left. Okay? We're going to write x to the power of n times -1 as x to the power of n and then to the power of -1. If you are here, you know what is power rule. Look at it here. This power has a base, x to the power of n. The base is the power itself, right? So by the power rule, we keep the base x, we multiply the two exponents. So you can see the two expressions are identical. So far, so good? All right. Remember, earlier we got a conclusion. We proved apply -1 on a quantity. You see, apply -1 on a quantity is equivalent to taking the reciprocal of that quantity. Do you see that? So that's the right-hand side. I proved the left-hand side equals the right-hand side. Yeah, I used the formula we got earlier. The -1 power is equivalent to taking reciprocal. Okay, let's look at the examples. It's going to be example 7. We have 7 formulas in total, so 7 examples. Let's see the first one, evaluate. Let's see, start from easy case. Yeah, let's see this. The first one, x to the power of -3. As I mentioned earlier, a while ago, I said our expression is not simplified if the expression has a negative exponent, right? So when you simplify an expression, you do have to get rid of a negative exponent. Here, number 1, we have x to the power of -3. How do we get rid of the -3 exponent without changing the value of the expression? This one should be easy. Just straightforward apply the formula. X to the power of -3, what is it? X to the power of -3, what is it? Okay, look at the formula. X to the power of -n. Behind me, number 6. X to the power of -n equals 1 over x to the power of n, right? Yeah, tell me, how do you apply the formula? And what do you have? Hello? Use 1 to over. Okay, that's how you get rid of the negative exponent. x to the power of -3 is 1 over x to the power of 3, right? Because the negative sign, the -1, the negative sign here in the exponent is equivalent to taking reciprocal. Remember that? Yeah, -n is n times -1. That -1 in the exponent is equivalent to taking reciprocal. Number 2, 2 to the power of -4. Evaluate 2 to the power of -4. Get rid of the negative sign. What do you have? 2 to the power of -4. Get rid of, we want to get rid of the negative sign here, right? The negative sign in front of 4, right? How do we get rid of it? Remember the -1 in the exponent is equivalent to what? Reciprocal. Okay? Do you guys understand my English? I wonder. Do you see what I'm talking about? Reciprocal. So that is 1 over 2 to the power of 4, right? The negative sign in front of 4 disappear because we used it already. That is equivalent to 1 over, right? Taking the reciprocal. So we have a reciprocal of 2 to the power of 4. Am I clear? What is 2 to the power of 4? 2 to the power of 4 is 2 times 2 times 2 times 2. What is it? 16, yeah. So the answer is 1 over 16. Okay? Yeah, you need to know something like that for test 4. All right. We finished all the 7 formulas. All the 7 formulas. Product rule, quotient rule, power of a product, power of a quotient. We did those yesterday. Today we covered 0 product, so 0 exponent and the negative exponent formula. Those are prepare us for study polynomials. Okay, so those formulas is to get us ready to study what? Polynomials. Okay, polynomials. So the focus of this chapter, chapter 5, are polynomials. Okay, let's take time to understand what is a polynomial. Let's take time to understand what is a polynomial. Please take notes. For univariate monomial, or you can copy this table here. I'm going to explain what is polynomial, right? Polynomial. Poly means many. P-O-L-Y. Poly means many. And we start from understanding monomial. Yeah, monomial. M-O-N-O. What does M-O-N-O mean? 1. Yeah, monomial. Yeah. So we start from understanding the definition of a monomial. Yeah, monomial. Monomial, some monomials only contain 1 variable, and that monomial is called a univariate monomial. Uni means 1, right? Are you guys with me? Yeah, uni means 1, variate means variable. Univariate monomial means the monomial only has 1 variable. Okay, multi means more than 1, right? Yeah, multivariate monomial means the monomial has more than 1 variable. Let's look at the definition for univariate monomial first. Let me state the definition for univariate monomial. Super important. Anything which can be written in the form. In the form, there are 3 parts. A, X, N. Any expression which can be written in the form A times X to the power of N is a monomial. Okay? Yeah. What is a monomial? Anything which can be written in the form here, a times x to the power of n. That is a monomial. Let's look at the three parts in the form closer. The first part, a, is the coefficient of the monomial, or numerical part of the monomial. So you can write it down. A here is the coefficient or numerical part of the monomial. It could be any real number. Means the coefficient of the monomial could be positive, could be negative, could be zero, could be fractions, could be decimals, could be rationals, could be irrationals, right? Yeah. A here, the coefficient could be any real number. So once again, it takes memory. Learning mathematics is natural science, but it takes a lot of memory. You need to remember. Okay. Second part is the variable base. Most of the time we use the variable x as the variable base. Maybe sometimes we use y. Maybe they use a or b or any letter, right? So you're gonna know that is a variable base. That is easy. The third part in the form is the exponent on the shoulder of the variable base. The important thing is you need to know, you need to remember. The third part, the exponent on the shoulder of the variable, has to be a whole number. Take notes, those details needs to be on your note. Yeah, the n here is also called degree. D-E-G-R-E, degree. Degree has to be a whole number. This is different from the coefficient. Coefficient could be any real number. The three parts in the form, two of them are numbers, right? A and n are numbers. X here is the variable. But the two numbers play different role. A here is coefficient in front of the variable part. It could be any real number. That, as I say, could be positive, could be zero, could be negative. But n here has to be a whole number. Okay, we did learn whole number in chapter 1. Anyone can tell me what's the smallest whole number? Yeah, good. The smallest whole number is 0. Exactly, yeah. So the exponent would be could be 0, could be 1, 2, 3, 4, and so on, so on, so on, right? Okay, that's the definition. Complete the definition for univariate monomial. Let me repeat. Univariate monomial only has one variable. Any expression which can be written in this form is a univariate monomial. In the form, there are three parts. Part 1, coefficient, the number in front of the variable part, or you can call, it's also called numerical part or coefficient. This number could be any real numbers. Could be any real number. Could be irrational or irrational. Could be fraction or decimal. You know. Second part is easy. The variable base. Yeah, this because it's univariate monomial. There's only one variable base. Third part, on the shoulder of the base, we have a degree. The important thing is the degree has to be whole number. So n here cannot be -1 because -1 is not a whole number, right? N here, the degree here cannot be half because half is not a whole number, right? Okay. Okay. In order to see if you really understand the definition, let's look at those expressions below. And we're going to determine. We're going to look at, did you see on the bottom? We have 1, 2, 3, 4, 5, 6. 6 expressions. We're going to determine which of them are monomial, which of them are not monomial, okay? Yeah, so far we're talking about univariate monomial. Let's look at the first one. -2 multiplied by x to the power 3. Look at the definition and then look at our expression. Determine, is -2 times x to the power 3 a monomial? Okay, we need to remember the name, monomial, super important. Intermediate algebra. So the last chapter of inter algebra we study polynomials, right? When you go to intermediate algebra, you're gonna study it again, polynomials, and then you go to factor polynomials, and then you operate the polynomials. So polynomial is super, super important. And monomial is a unit, is a smallest unit of polynomial. Okay, anyone has a answer? Has an answer? Yes or no? Yes or no? Yes. Tell me what's the coefficient, please? Coefficient. -2. Could the -2 okay? Could the coefficient be -2? Is it negative? Is that okay? Yeah, it's okay because the coefficient, remember, coefficient could be any real number, right? What's the variable base? What's the degree on the shoulder of the x? 3. Is 3 a whole number? Yes, okay. So this is a monomial, no problem. Let's look at this expression, 1 times x. Yeah, actually, I shouldn't have write 1 there. So what if you only see x? Is x a monomial? Is x a monomial? Yes, right? Yeah, what's the coefficient? 1, yeah. What's the degree? Degree of the monomial is the exponent. What's the degree? Degree is 1 as well, right? Okay, perfect. So yes, this is. Look at the 10. Determine if number 10 a monomial. Determine if the number 10 a monomial. It has to contain all the 3 parts. Yeah, this would be challenging, so I'm gonna write here for you. 10, could we write 10 as 10 times x to the power 0? Yes? Because why? Because x to the power 0 equals what? Because x to the power 0 is 1, right? So we could write 10 as 10 times x to the power 0. All right, look at this part. What's the coefficient? What's the variable base? What's the degree? Degree is 0, is 0 whole number. Yes, yeah. So tell me, is 10, the number 10, a monomial? Yes. Look at the 0. Same idea. Can you determine on your own? Is number 0 a monomial? Yes? Okay, the same thing, right? Because we can write 0 as 0 times x to the power 0, right? Coefficient. Coefficient is 0, real number. Variable base is x, degree 0, whole number, right? Okay. What about 95? Is 95 a whole number? Yes, same thing, right? Degree 0 as well. What about half? Same thing. They are all the same. Okay? All the same. So please write down a conclusion. A constant is a monomial with degree 0. A constant. The constant could be any real number, positive or negative or 0, decimal or fraction, rational or irrational. Yeah. A constant is a monomial with degree 0. Like those numbers we saw earlier, right? Okay, please remember this this conclusion. Please remember this conclusion. Any questions so far? And then let's see, what is a multivariate monomial? Multivariate monomial. We mainly deal with univariate monomial, but we need to know or identify. We should be able to identify what is multivariate monomial. Yeah, let's just look at this expression. This expression, -27 x cubed y squared z to the power 1, has a coefficient -27, right? Yeah, coefficient power 1. First part, coefficient. Power 2, variable base. And it has 3 variable base. So that makes the monomial multivariate monomial, right? Yeah, on each variable base, power 3 exponents or degree. Sorry, exponent is more accurate here. Exponent on the shoulder of x is 3, right? 3 is a whole number. Exponent on the shoulder of y, 2. 2 is a whole number. Exponent on the shoulder of z is 1. 1 is a whole number. So it satisfies the the conditions in the univariate monomial, right? The only difference is this one has more than one variable. Now there's a part you need to remember. How do you determine the degree for a multivariate monomial? Univariate monomial is easy, right? Whatever the exponent, that's the degree of the monomial. What if the monomial is multivariate? What's the degree of the multivariate monomial? Do you see this 3, 2, 1? You add them up. 3 plus 2 plus 1. What do you have? Yeah, degree of this multivariate monomial is 6. Yeah, if you want, you should write it down. How do you determine the degree for a multivariate monomial? Add up those exponents. Take the sum of the exponents. Am I clear? Okay. So let's look at, yes, please. Negative 27, right? Negative 27. That's the coefficient. Coefficient could be any real number. Yeah, like a univariate monomial. As I wrote here, coefficient power 1, right? It could be any real number. So it could be negative. Did I answer your question? Yeah, you just keep it. Yeah, the coefficient in negative 27 is a constant. You don't really could do anything. All right. So did we just learn monomial? Can you, if you were a mathematician, can you give the definition or meaning for binomial? Yeah, we just learned what is a monomial, right? What do you think binomial should be? 2, 2, right here is a 2, right? Yes. Binomial is the sum of two monomials. Binomial is the two monomials added together. Okay, binomial is the sum of two monomials. What about trinomial? 3, yeah. Trinomial is the sum of 3 monomials. Is that obvious? And what if the expression has 4 monomials? We do not really have a specific name. They are all called a polynomial, okay? Monomial, binomial, trinomial, any expression contain one or more monomials is called a polynomial, okay? Polynomial. So they are all called a polynomial. Please let me know, am I clear about the definition of a polynomial? Well, what does polynomial should look like? In polynomial, we have one or more monomials added together, right? Okay, let's look at some polynomials. All right, let's see. Let's see this table. Let's look at this table. We're gonna explain 2 concepts for a polynomial. Leading coefficient of a polynomial and leading term of a polynomial. So we start from leading term. We learned term in chapter 1, right? So if you look at the structure of a monomial, that is one term, okay? That is one term, right? This is the numerical part. This is the variable part, right? Yeah, so sometimes we call monomial as a term. Monomial is a term. Term might not be monomial, but monomial is a term. Okay, so in a polynomial, the term with the biggest degree is the leading term of the polynomial. That's the definition. It's like your name is Angela, your name is Saria. It's defined like that. Okay, let me repeat. What is the leading term? Leading term of a polynomial is the term with the biggest exponent. For example, let's look at this one. 3x to the power 4th minus 5x squared plus 6. How many terms? 3. Are those terms monomials? Are those terms monomial? 3 parts, right? 3 base degree, coefficient base degree. Remember, one constant is a monomial with degree 0, right? Okay. What's the degree of this part? Exponent 4, right? What's the degree of this one? 2. What's the degree of this one? 0. A constant is a monomial with degree 0, remember? Degree 0, okay? Yeah. Which one has the biggest exponent? So this is the leading term, okay? Leading term. Let's look at this one, 5x plus 7. Is this a monomial? 5x? Is 5x a monomial? What's degree? 5x. What's the exponent on shoulder of x? Degree 1. Yeah. Is 7 a monomial? Angela, what's the degree of 7? Yeah, awesome. So which one has a bigger exponent or degree? 5x, right? 5x is the leading term. Very good. And let's look at this one. X to the power 5 plus 3x to the power 6 minus 7. Is this a monomial? Degree 5. Is this a monomial? Degree. Are you able to see it? Degree 6. Negative 7 degree 0, right? Which one has the biggest exponent? 6. This one is the leading term, okay? Sometimes the leading term is not in the first term. It's not the first term. You have to identify it using the definition. Okay, this one. Is this a monomial? 5y squared. Why do we find the leading term? Because we need to know what is the leading coefficient. That's a good question. Leading coefficient is an unimportant concept. Leading coefficient is the coefficient of the leading term. For example, the first one, 3x to the power 4 is the leading term, right? What's the coefficient of the term? So 3 is the leading coefficient. Yeah, of course. Yeah, of course. We are still in the phase of getting to know polynomials. A lot of things in polynomial, those components. And what's the leading term of this one? 5x plus 7. Leading term, what's the leading coefficient of the polynomial? 5. Leading coefficient is a number, right? Yeah, 5 is the coefficient of the leading term, so it's the leading coefficient. And what's the leading coefficient of this one? 3. Yeah. Okay, let's look at this polynomial, the last one in green. 5y squared plus xy minus 2x squared y. How many variables do you see? How many variables do you see? How many variables do you see? 2 variables, x and y, right? So this is a multivariate trinomial. Okay, let's see what's the degree of this guy, 5y squared. What's the degree of 5y squared? Bless you. 2, awesome. Let's see the second term, xy. What's the degree of x times y? Another 1. Yes, how do you get a 2? You have 1 here, 1 here. Remember, you add them up, right? Do you see that? It's 2 as well. And what's the degree of the term 3? Here you have 2. You should have a 1 here. What is it? What's the degree of this term? 3. You have 2 here, you have a 1 here, right? So this term, negative 2 x squared y, is the leading term. Coefficient negative 2 is the leading coefficient. Yeah, we need to know the concepts. And those are our practice about the definition of polynomials.
But there's also that the left side and the negative side, like they divide the variables. And I said 3, right? Because there's 1 to 3 spots.
It's a trinomial, yeah. It's a trinomial. What was your question? Yeah. Yeah, 3 terms.
Okay, so 3 terms, 2 variables. Okay.
Yeah. 2 variables, so it's multivariate. 3 terms, so it's a trinomial, right? Yeah, you would have something like that in my lab math, but my test might not have much about a multivariate. My test all about almost about univariate. Okay, next up, a very important definition. What definition? Standard form of a polynomial. Okay, yeah, we need to know, write a polynomial in the standard form. Yeah, I'm not going to give you the definition for standard form. I'm going to show you how to write a polynomial in a standard form, and you should know what is the standard form of polynomial, okay? Yeah, so let's take the 3 polynomials in the table as example. The first one is 3x to the power 4 minus 5x to the power 2 plus 6, right? Okay, what's the degree of this polynomial? Degree. What's the degree of this polynomial? 4. Okay, identify the degree and then add 1, always number 1. Add 1 on the degree. What is the 4 plus 1? 5. Okay, you need to remember, okay, you identify the degree and then you plus 1. The number is going to be the how many terms in the standard form of the polynomial. So you are going to have 5 terms in the standard form of the polynomial. Let me show you what are the 5 terms. Start from the leading term always. Degree is this is a univariate, right? Yeah, that's a good question. For univariate polynomials, the degree of the polynomial is the degree of the leading term. Yeah, that's the reason we need to identify what is the leading term. Yeah, leading term. That's a very good question. Okay, so we write the leading term first. 3x to the power 4. Do we have the term with x cubed? Do we have the term as with x cubed? We have x to the power 4, right? Do we have x to the power 3? No, okay. If no, you're gonna write 0 times x cubed. The reason you do not have x cubed in the polynomial is because the coefficient of that term is 0. 0 times anything is 0, right? It won't change the polynomial, but you have the term with degree 3. Do you see what I'm talking about? That's the standard form, because we are running the polynomial in the standard form. The standard form is going to have all the degree terms. If the degree is 4, you're going to have term degree 4, term with degree 3, term with degree 2, term with degree 1, term with degree 0. So that's the reason you have 5 terms. Yeah, that's a good question. Yeah. So do we have degree 2? Do we have a term in with degree 2? So 95x squared, right? Do we have a term in the polynomial with degree 1? Where? No, we don't, right? If you don't, you write plus 0 times x. 0 times x to the power first. Okay? Okay, do we have degree 0? 6, right? All right, so this is the standard form. Yeah, I'm not going to write a definition for you or the formula for standard form. I'm showing you what is standard form and how do you write a formula in the standard form. 3 examples. Identify the degree first. In this case, degree is 4. Add 1, you would have the number of terms going to be in the standard form. If the degree is 4, you are going to have 5 terms. And those 5 terms are term with degree 4, term with degree 3, term with degree 2, term with degree 1, term with degree 0. The whole set. Yeah, if you are missing a term, just write the term out with coefficient 0. And in the standard form, you can see the terms are in the order. The terms are sorted in the descending order of the exponent, right? Descending order of the exponent. Am I clear? Don't worry, we're going to practice more. Let's look at the second problem. Second problem is 5x plus 7. What's the degree? Angela, what's degree 5x plus 7? Degree. Degree is a number, it's a whole number. Degree, that's coefficient, leading coefficient. Degree is the exponent, right? Yeah, it's a binomial. This term, degree 1, right? Because it's x to the power first. This term is degree 0. Remember, a constant is a monomial with degree 0. Okay, what's the degree of the polynomial? You ask the question. The degree of the polynomial is the degree of the leading term. So what's the degree of the polynomial? 1. Okay, what is 1 plus 1? 2. Do we have 2 terms already? Yes, and our 2 terms in the order are sorted in the descending order of the degree. Degree 1, degree 0. So means what? Means this is already in a standard form. Okay, this is already in a standard form. Am I clear? Sammy, any questions? Yeah, we need a wake up when we learn mathematics. I know it's pretty early, right? It's almost 10, yeah. Number 3. The polynomial is x to the power 5th plus 3x to the power 6 minus 7. Yeah, why do we spend time to learn standard form? Because we need it. Need it for what? We need it for operations of polynomials, because the rest of the part of the chapter, we're going to learn how do we plus, how do we minus, how do we multiply, how do we divide polynomials. We need to know the standard form of a polynomial. Let's look at number 3. And tell me what's the degree of the polynomial. 6. Awesome. What is 6 plus 1? So we are expecting 7 terms in the standard form, right? Yeah, we are going to have 7 terms in the standard form. Start from the leading term, which is 3x to the power 6. Do we have the term with degree 5? Yeah, okay, just copy it. Do we have a term with degree 4? No, okay. What do you do if you know? 0 times x to the power 4, right? Awesome. Do we have a term with degree 3? No. Same thing. Degree 2? No. Degree 1? No. Degree 0? -7. Yeah. You see that? 1, 2, 3, 4, 5, 6, 7, right? Yeah. 7 terms in the standard form. And degree 6, degree 5, 4, 3, 2, 1, 0. You're going to have the whole set, the full set. And that's the standard form of that polynomial. I think that should be enough for us to understand what is standard form and how do we write standard form, right? 31? Yeah, if the degree is 30, the standard form has 31 terms. But we do not process polynomial has that many terms. Yeah, we don't have that big polynomials. If the degree is higher, we normally use the calculator, computer, the program. Yeah, our focus is to get a feeling to understand the concept of polynomials. Any question about what is monomial? Yeah, we focus on univariate monomial, okay? Yeah, let's think about what is a univariate monomial. Yeah, what does it look like? Three parts. What's part 1, part 2, part 3? The degree has to be whole number, right? And what is a binomial? If you have two monomials add up together, that's a binomial, right? What is a trinomial? Yeah, what is a regular polynomial? Yeah, by the way, the sign is part of the monomial, okay? Yeah, the negative sign, -7 with the sign, that's one monomial. That's the reason I say trinomial is the sum of 3 monomials, right? This plus -7. Yeah, plus -7. Okay. Any question about the definition of polynomials? Degree, leading coefficient, standard form. Okay, now let's start the operations of polynomials. We're gonna see how do we plus, how do we minus. We have 20 minutes, pretty much like that. And then tomorrow we're gonna do multiplication and Thursday division, Friday review for test 4, Monday test 4, Tuesday final. That's the plan, okay? That's the coming Monday test, yeah. Tuesday final exam. It's in the syllabus. Yeah, we only have 8 weeks, unfortunately. It's not even 8 weeks, I think. It's not even 8 weeks. 7, only 7 weeks, like two more days. Yes. Huh? I don't. Oh, after this, the same classroom. I have a 8-week intermediate algebra. I don't know if you registered. I don't know if with you or not. I guess at least have most of the time has a few. So they take intro algebra 8 weeks and then follow with the intermediate algebra 8 weeks. That is intense. Fortunately thing is intro algebra is very easy. Intermediate algebra is a different level. Okay, what I'm talking about, yeah, we're gonna see how do we operate polynomials. Where's my questions? All right. We only give one example for addition, given one example for subtraction. Question? Yeah. Let's see, how do we add? We're gonna add 9x cubed minus 2x squared plus 4x minus 6 and -2x cubed plus 7x squared minus 9. Okay. We are taking the addition for 2 polynomials. One is in blue, the other is in green. We are adding them up. I'm going to show you 2 different methods to adding 2 polynomials, okay? Method 1. The first method is called a vertical method. The first method is called a vertical method. Let me show you the method. We are going to align the 2 polynomials vertically. Okay, I'm going to put the blue on the top. Okay, it's 9x cubed minus 2x squared plus 4x minus 6. Tell me please, is this polynomial in blue already in a standard form? Yes, yeah. 4 terms, degree 3, right? Okay, I'm going to write a green polynomial right below the blue. And the important thing is, I need to make sure all the like terms are aligned. For example, negative 2x cubed, degree 3, right? I put that polynomial right below 9x cubed. This way, vertically, look at the polynomial, look at the terms, they are like terms. Do you see what I'm talking about? Okay. And the second term in the green is 7x squared, 7x squared. And it's aligned with negative 2x squared, right? Okay. Negative 9. Yeah, let's see. Could I write negative 9 here? Could I write negative 9 here? No. Okay. Look at the green polynomial. What's the degree of the green? What's the degree of the green? 3. So the standard form is supposed to have 3 plus 1, 4 terms, right? Is the green in the standard form already? Is the green in the no, not yet, right? So which term is missing? Degree 1. So we make it up 0 times x, right? Yeah, and then minus 9. So very important. When we apply vertical method to add 2 polynomials together, yeah, we put them vertically. We need to make sure all the terms are like terms. All the like terms are aligned. Yeah, let me write it down. We need to make sure like terms are aligned. Super important. People make a mistake because maybe, okay, minus 9, they put a 9 here. Yeah, you cannot operate 2 terms if they are not like terms. Am I clear? Yeah, vertical method. Make sure the 2 polynomials are aligned vertically. And then let's see, things gonna become easy, right? And you're gonna add them up. 9x cubed minus 2x cubed. What do you have? 9x cubed plus negative 2x cubed. What is it? 9 minus 2. 7x cubed. Very good. Negative 2x squared. Yeah, negative 2x squared. Positive 7x squared. Combine like terms, what do we have? Negative 2 plus 7. Negative 2 plus 7. 5. X squared. Very good. 4x plus 0x. 4x plus 0x. 4 plus 0. 4. Okay. Constant term. Negative 6 plus negative 9. Negative 15. Here we go. That's the definition. That's the answer. Okay, minus 15. Minus 15. That's the answer. That's the vertical method. Any questions? The important thing you need to remember when you apply vertical method, vertically, the like terms has to be aligned. Okay. Second method, method number 2, is called a horizontal method. Horizontal method. Let me show you how do we apply a horizontal method to add the 2 polynomials together. So we copy the first polynomial. With the horizontal method, you do not have to worry about standard form, align like terms. You don't have to worry about that. Yeah, I copy the blue polynomial, and then I copy the green polynomial because you are adding them up, right? So I add them up, put them together. Yeah, the blue has 4 terms, the green has 3 terms. We put them all together. Horizontally, we add them up. Very easy. But we have to simplify because you can see this and this, they are like terms, right? And this and this, are like terms. This and this are like terms, right? Yeah, let's combine like terms. Orange, orange. 9, -2. Orange, orange. 7x cubed, right? Purple, purple. -2 plus 7. 5x squared. Yellow, yellow. -15, right? Yeah, we have one more terms here. Be careful. There's no like term with it, but it's still there. Don't lose it. We bring down 4x. So you have the same thing with earlier. Yeah, the answer, the addition is the same with earlier, of course. Yeah, two different methods, of course, will give you the same correct answer. I wanna ask you, which of you like method 1, vertical method? 1, 2, 3, 4. Okay. Which of you like a horizontal method? 1. Okay, vertical method win. Okay, so it doesn't matter. It really doesn't matter which method, as long as you get the right answer. Yeah, you prefer a vertical method, but you need to be careful when you line them up. The like terms has to be aligned. Yeah, like this case, if you are not careful, the green term is missing a term, right? You might mess it up. Okay, that's addition. Addition. Adding two polynomials. We gave two methods, a vertical method and a horizontal method. Now let's see subtraction. Let's see subtraction. Let's just use this as an example. Hello. Which class you are taking mine? Oh, Calvin, right? Okay. So let's see the second example. Subtraction. Example 2. Subtraction. So subtraction means you minus a polynomial from another polynomial, or you use one polynomial to minus another polynomial. You understand what I'm talking about? Okay. So in this case, so let me write it down. Find the difference of 6x fourth plus 6x squared minus 2x and -7x fourth minus 4x squared plus 3x. The important thing is we need to know the difference of A and B means A minus B, not B minus A. That's not a 6, by the way, that is B. The difference, yeah, in algebra, we have the grammar as well. Yeah, the difference of A and B refers to A minus B, not B minus A. So when we take the difference of the blue polynomial and the green polynomial, you need to know you are looking for the blue minus green, not the green minus blue. Am I clear? Okay, as I said, I'm going to show you two different methods. Method 1, vertical method. Vertical method. Okay, subtraction of vertical method is a little bit challenging. I'll show you. So you put the blue polynomial above, and you put the green polynomial below. Similar with the addition, yeah, you also have to make sure all the like terms are aligned. Yeah, look at here. Fourth, degree 2, degree 2, degree 1, degree 1, right? And so we don't have that problem. Yeah, the two polynomials are aligned. We are using blue minus green, so blue is above, green is below. Okay, we are minusing. Yeah, so here we have minusing. We are going to translate or transform that expression or the diagram as this. We keep the blue polynomial, the polynomial above, and now we're going to change this. We're going to change the minus to addition to plus. Change the minus to plus. And now we are going to change all the terms in the green. So we copy blue. Blue doesn't change. For the green, we are going to change every single term in the green to its opposite. The first term, negative 7x fourth. So we're going to write it a positive 7x fourth. Do you see what I'm talking about? And second term, negative 4x squared. We are going to write it a positive 4x squared. Third term, 3x. We are going to write it a negative 3x. So that's green. So here, blue minus green. You write it vertically as blue plus opposite of green. What is the opposite of green? It's easy. Simply just flip those signs. Negative becomes positive, negative becomes positive, positive becomes negative, right? And you do the addition. Yeah. Earlier the vertical method 1, right? So you like the vertical method. Let's add them up. 6 plus 7. 6x fourth plus 7x fourth. 13. 6 plus 4. 6x squared, 4x squared. 10, right? Negative 2, negative 3. Here we go. That's the difference. Do you like this method? Yeah, when you subtract, when you use blue to minus green, you copy blue, but flip the signs in green. So minus a quantity is the same with plus the opposite of the quantity, right? Same with here. That's how do we operate subtraction of polynomials vertically. Any questions? If not, let me show you the second method. Second method is called a horizontal method. Second method is a horizontal method. Since, as I said, we have to finish everything this week, you don't have much time to practice in the class. So my lab math is your practice. They due next Tuesday. Okay? Everything due next Tuesday. So make sure you know. Okay, let's see, how do we take the difference of two polynomials horizontally? Okay. We're gonna copy the blue. Copy the blue. Right? That's the blue polynomial. And minus the green. Yeah, what's the green? Green is negative 7, negative 4, positive 3x. Is this too easy for you? Is this too easy for you? Okay. I can make it difficult if you think it's too easy. We have a blue polynomial minus green polynomial. Right? So horizontally, you just copy them down. Blue in a parenthesis, minus, very careful, green in a parenthesis. And now let's see, how do we remove the parentheses? Very important. You need to know the first parenthesis, coefficient of the first parenthesis is what? 1. So it means nothing, right? So if the coefficient of a parenthesis is 1, you can really literally remove the parentheses. And now let's see the second parenthesis. Tell me what's the coefficient of the second parenthesis? Negative 1, right? It has a negative sign in front of it, so the coefficient is negative 1. Okay, let me tell you. I think we had this covered in chapter 1. If you don't remember, I'm going to repeat it here. If the coefficient of the parenthesis is negative 1, when you distribute, when you remove the parentheses symbol, all the terms in the parentheses are going to become its opposite. Okay? So, since the first parenthesis has a coefficient 1, we literally just copy the polynomial, the blue polynomial. Since the second parenthesis has a coefficient -1. All the terms in the green gonna become its opposite. So negative becomes positive, negative becomes positive, positive becomes negative, and then you copy, and then you combine like terms. Orange, orange, like terms. Purple, purple, like terms. Yellow, yellow, like terms, right? Orange, orange, you have 13. Purple, purple, you have 10. Yellow, yellow, you have 95. That's a horizontal method. Yeah, so for subtraction, we also have two methods, vertical, horizontal. Which of you like a vertical better? Okay. Which of you like horizontal better? Okay, this time half, right? And so you don't like either? You guys don't raise your hand, so you don't like either? The two methods? Oh, okay, I didn't see you, sorry. So vertical still one. We're gonna continue operations with polynomial tomorrow. Thank you guys for coming.